Welcome guys in this continuous series of the signals in the digital signal processing. So guys, in the previous videos we have discussed some signals in the DSP, and in this today video we will discuss the signum function signal in continuous time and discrete time signum function in DSP. So one by one we will discuss. So guys, before starting the video I want to tell you, please subscribe my channel, like the videos, and if you have any query regarding this, please write in the comment section. So let's start the video. So first, what is signum function? Basically our signum function signal in DSP. So signum function is a signal, so it is same as the unit step signal, but the only difference is the unit step signal is applicable only for the values are greater than 0 of t. The value of t is greater than 0 in the unit step signal, so only applicable for positive values, and the signum function is applicable for positive as well as negative values both, but as same as unit step signal. So here x of t represents that signum function represents the SGN, and of t is the signal, so t is the continuous time signal. So this is the 0 and origin from 0 to here infinity. The value of the signum function is has 1, it has positive amplitude 1 from 0 to t, 0 to plus infinity. It has constant amplitude of 1, and for the 0 to minus infinity or less than 0, it has the constant amplitude of minus 1. So for both the minus infinity to positive infinity, it have the flat amplitude in the positive as well as negative values. So this is the signum function in the continuous time signum function in DSP. So the continuous time signum function is the mathematical representation of this signum function t of continuous time signum function. That is, when the value of signum function is 1, then the t value is less than, t value is greater than 0, or when the value of the t are positives, and here when the value of t is positive from greater than from 0, so it has the signum function, the value of signum function is 1, and when the value of t is in the negative values or less than 0, then the value of this signum function is minus 1, or amplitude of this signal is minus 1, or simply we can say when the amplitude of signum function is 1, then the value of t is greater than 0, and when the amplitude of signum function is minus 1, then the value of t is less than 0. So this is for the continuous time signum function. Here this signum function is odd, is for odd signal or antisymmetric function. So let's move to the discrete type signum function. So guys, discrete type signum function is also same as this continuous type signum function. So here this is the continuous signum function, and this one is the discrete type signum function. So here in the discrete time signum functions, we find out the internal digital or discrete sample value samples, means these are the samples of this continuous or flat continuous signal. So this is a flat continuous signal of flat amplitude of -1, flat amplitude of 1 in the positive values. Here the amplitude is 1 of all these values. These values for 0, this values for 1, for 2, 3, 4, for different values. All the values have the same amplitude 1 in the positive side. So when the value of n, here we represent the discrete signum function with n. So when the values of n are positive or from greater than 0, then the signum function x of n is have positive amplitude, means 1, and when the values of n is less than 0, so then the signum function have the negative amplitude of 1 for all the negative values. So mathematically representation of this discrete type signum function is mathematically representation. So x of n represents the signum function in discrete form. So x of n, that is equal to, when the signum function is 1, then, or for the value of n is greater than 0, and when the signum function is -1, then at that particular time the values of n is less than 0. So this mathematical equation will be applicable in this discrete time signum function. So it will simply as the unit step, same as a unit step signal. Here if we remove this part, if we remove this part from this signum function, or if we replace these values to 0, then this will behave like a unit step, and if we replace again 0 values to these negative values, then it will work as signum function. So that's all for this video, guys. If you have really get something from this video, then please subscribe my channel, like the videos, and if you have any query, please write in the comment section. So thank you, guys.